Hi, hello again. As you might have seen from my previous video, I was talking about the new section of my layout and the fact that I would be dismantling the two helixes, one on each opposite side of the layout, which I call east and west helixes. As you can see from this video, well, both of them are dismantled. So west one on that side and the east one on this side. So it's now time to start building the new helixes with the largest radio, and we're going to see, well, at least I will try to show you how I'm planning to do it, with a couple of important aspects before proceeding to cut the plywood subroadbed sections. One other important aspect is the fact that because I'm not changing, just let me take this out of the way here. Because I'm not changing, let's call it the anchoring points of the layout, so these two tracks will not be changed. I need to keep the reference supports where the last, let's say, section of the helix will be landing, and this is the case. So I'm pretty sure that the helix will be standing here eventually some centimeters backwards or in this direction, because the radius will be larger, so it means that I will have to move a bit farther away from those tracks, the new helix. And of course the same happens on the opposite side. So we'll now move into the next video segment, where I show how I'm preparing the templates for the for the new helixes. Hi. So as I mentioned earlier in the video, I mean, I'm preparing now, or let's say the first step before preparing the actual templates that I'm going to use to cut the plywood for the subroadbed. And to do this, I must make sure that the new radiuses and the clearances between the both tracks and the limits of the subroadbed, which are here. I will just zoom this a bit closer so you can see the line I've drawn here. So we have one line on one side and another one on the other side here. Okay, and I know that these two lines have a width of 16.5 centimeters or 165 millimeters, depending on the scale you prefer to use. So I know this is going to be my limit, and I must make sure of two things. One is that the coaches, the largest coaches I have in my layout, will not collide either here, there, or between them. But before proceeding with that, I will show you how I've made these curves, because I'm using flexible track, and fortunately I decided to do with flexible track the helixes instead of sectional track. Sectional track has a big advantage that, I mean, let's say the radius is preformed. Okay, so there is no mistake about the radius of the curves. On the other hand, they are much more expensive than the flexible track, and obviously they are not flexible. And that's a big disadvantage when it comes the time that you need sometimes to adapt the way the track it's moving, or the path of the track, better saying, to adjust to the existing anchoring points on the layout. So to do this, I've used these templates, these track set templates, which if you are using, if you are working with flexible track, I do recommend to get this. They are not cheap, I think I got this, several of them on around 10 euros each, so they are a bit pricey, but they are really valuable. And they will last a lifetime. They are forever. So, I've used this template, so sliding them back and forth until I got the curve radius I needed, and just for the sake of testing it, I pin down the tracks, but typically I glue the tracks instead when they come to the definite position. So to do the limits, to trace the limits, I've used a card like this, okay, and a device I've made in my 3D printer. So here you can have a better look, okay, which fits in the kernel like this, okay. You can see here, and which has a pencil attached, and with this I can mark, okay. You can see here on both sides. If you don't have a 3D printer, obviously you can do this with some some wood, plywood or hardboard, whatever. But if you are into the hobby, for quite a while, and I do recommend that you get a 3D printer, because it helps you a lot, not only for structural elements like this, but even for buildings and or small details, or even signals, semaphores, whatever the imagination, your imagination wants to use it for. And in that case, I do recommend, instead of a filament printer as this one, you get a resin printer. So now, once I've established the limits, the distances between the tracks, now I have to test them to make sure that they will not collide either with the limits of the subroadbed or the coaches between them. So I've decided to use my longest coaches I have. As you can see here, they will not collide with the limits on both sides, neither between them. And another important aspect is that, and that's why I've used two coaches on the let's say the curve with the smallest radio, is to make sure that there is enough clearance between the coaches to make sure that the contact points here do not tangle between themselves, okay? That will lead to derailments, okay? So these are dynamic couplers that can extend when there is a bit more of pulling, okay, from the locomotive. So, and you can see this is good enough, at least for me. And that's it. So now to the template drawing and cutting. Hello. So welcome back to the video of the section of what I'm trying to make the template for the subroadbed of my new helixes. We have to make sure that when we make the template, and in my case I'm using a 90-degree template, which means I will have to use 4 for each complete turn of the helix. We are using a precision as higher as possible, especially, obviously not only when drawing the template, but obviously when cutting it, because then we are going to use the template, which in this case is made of hardboard, to cut the actual subroadbed, which is in my case made of 10mm plywood for strength and stability. So in order to do this, I've devised, you can call it a contraption, whatever you like, so that where I have a fixed point, or where I pivot let's say the pencil, what I'm going to use, to draw the arcs that compose the template. And before doing it, I've established a couple of lines here. You can see one here and the other one there, which are absolute square to each other, so a 90-degree angle here. And then, I mean, you can use either a simple steel ruler like this one, where you can do a couple of, well, in this case 3 holes, where the first one will be the fulcrum, so the pivot point, and the other 2 will be the inner and outer radius. We can do it with a simple steel ruler, or, because as I mentioned earlier, I have a 3D printer, I made these 2 devices where I put here in a rod, a simple 6mm steel rod. So this one will be the fulcrum. You can see here that it has a small hole, okay, what I put through a well, a small screw, okay, you can see here, where I fixed in the fulcrum here in the pivot, okay. And the other side, it's a let's say another support where I drive in a pencil, okay, sorry, let me get this, and then where I can draw it. Needless to say that the center of this support here is at the same distance to the rod as this one here, okay. So another simple thing that we should do before actually screwing in the pivot is to previously screw the same well, screw here, the same bolt, so that when we screw in this one, we are sure that it's exactly on the same point, because otherwise you will not be able to see it with precision. So okay, I can screw in here. All the way through. Make sure that it's flat here. Okay, give it some. Of course, before I have to measure, and in my case, I'm using an outer radius of 650. So I have to make sure that I adjust this properly. Okay. Apparently, it seems to be the case, but I will just double check to make sure. Okay, I'll come back to you in a while. Hi, so continuing with my previous video, I was just about to make the first trace of the largest radius for the template of the subroadbed sections, and I realized that the piece I've designed and well, printed in 3D printer was too small, so there was too much play here. So the pencil, you can see, was, you know, didn't give the guarantee of solidity. So I designed this new piece, which has a longer support here, and now the pencil is in a much stiffer position. So I'm just going to position it here in the rod. Just adjust this camera so you can see. Better. Okay, so I'll make sure that by adjusting here that this is where it should be. So I'll try it again. In. Okay. So I have the outer radius, and now it's just a matter of marking here the inner radius, and then draw another line, and then I have the template. So now you see why it's very important that I have this line and the other one down there perfectly square. So this section here, this side here, will be perfectly square with the other one, which means that when I have 4 pieces like this, well, the actual subroadbed, not the template obviously, but those sections cut from the template, when they are together, they form well, perfect, or almost as much as possible perfect helix turn as possible. Okay, so hope you enjoyed. Thanks.